Thanks to UP Travel for sponsoring this video. This place is super peaceful and it's beautiful, right? Well, you can thank the exploding volcanoes. It's story time. I'm at Michigan's Porcupine Mountains Wilderness State Park, which is the largest state park we have and is entirely beautiful in every way. When people come here, they almost always hike or drive up to the Lake of the Clouds to see this view. And I get it, but my favorite view is actually the one under my feet. Because check this out. This is the top of a billion-year-old lava flow. And up there is another one, and then there's another one, and another one. Anyway, here's how you can tell. So this ridge is made of basaltic lava flows. Basaltic lavas are a type of lava that's relatively low in silica, and they're pretty runny for liquid rock. I mean, they're still 10 to 100,000 times more viscous or more thick than water, but it's all relative. So these lavas flow across the ground pretty easily, and any gases that are trapped inside, like water vapor or carbon dioxide, can escape. When those gases fizz out, they can leave behind bubbles in the top of a lava flow. And over time, those bubbles can get filled up with other minerals, which is what we see here. So this is the bubbly top of a flow. Now, if you look up here, you'll see an area with no bubbles. That is the bottom of the next flow. Here's the top, here's the bottom. So this lava flow was on the surface for some number of years, and then this flow came along and partially covered it up. But here's the question. Michigan is not exactly known for having a bunch of lava. So where did all of these flows come from? The short answer is the mid-continent rift. So about 1.1 billion years ago, what's now North America was in the process of ripping in two. This may have been driven by a big hot spot underneath the Midwest that softened the crust, or there may have been some kind of pulling force coming from out east, or both. One way or another, after tens of millions of years, the rifting stopped for some reason. And the end result was this enormous valley, going from Kansas to Lake Superior and then down through the lower peninsula. For tens of millions of years, this rift in the earth allowed runny basaltic lavas to flood across the surface in a series of countless individual lava flows, including those here at the now very pleasant Lake of the Clouds. Now, with this spot in particular, the lava isn't the entire story. After the rifting stopped, sand and sediments and stones began coming into this valley, carried along by rivers and streams. Over the eons, that sediment got buried by other material, was put under enormous pressure, and was cemented into sedimentary rock, stuff like sandstone. Then finally, and much more recently, like as recently as about 9,000 years ago, glaciers came through this area, scraped the heck out of the ground, and eroded a lot of the sedimentary rock. But this lava rock is much tougher and more resistant to erosion, so it stuck around, which is why we now have this gorgeous overlook. So you've got a cliff, a glacial carved valley, and then these hills in the distance. And those are kind of odd in a really cool way. See, the mid-continent rift represents a bunch of runny basaltic lava that generally piled up in fairly flat sheets. But on the horizon, what we're seeing is different. The echoes of at least one exploding volcano. Let's head over to Summit Peak, and I'll say more. Man, I really love this place, by the way. I love the Porkies. All right, let's go. So this is the Summit Peak Trail, and you'll notice that the rocks here look a little bit different than what we saw at Lake of the Clouds. This is also lava rock, but it didn't come from basaltic lava. This is rhyolite, and rhyolite forms from rhyolitic magmas and lavas. Unlike the basaltic stuff, rhyolitic lavas are viscous and thick. So instead of flowing across the ground, they tend to pile up in one place, creating these domes, these volcanoes, full of rhyolitic magma. By the way, magma is just underground lava, so if you hear me alternating between magma and lava, it's because sometimes I'm talking about stuff on the surface, and sometimes I'm talking about stuff underground. In any case, rhyolitic lavas tend to have a higher gas content than their basaltic cousins. And because the lavas are so viscous, it's really hard for those gas bubbles to get out. So they end up pushing against all this thick stuff, expanding but unable to go anywhere. And over time, pressure starts to build up inside this dome full of magma. Yes, it is just like having a bad case of gas. But hopefully what happens to these volcanoes does not happen to you. Because if that dome suddenly ruptures or cracks, what happens next can be incredibly violent. All the pressure inside that magma finally has somewhere to go, and that mass of molten rock can positively explode. When a volcano like this blows up, it can be so powerful that the remaining structure just collapses in on itself, forming a pit called a caldera. Then rhyolitic magma starts to ooze up from under the earth again, and the process repeats itself. This is the kind of event that happened here in the Porkies. There could have been one volcano or an entire volcanic complex, but in any case, Summit Peak is one example of a rhyolite dome. This is why you see rhyolite over here and not at Lake of the Clouds. This is the heart of the ancient volcano, and this stuff is a little bit of its magma. Elsewhere, geologists have also found what's called pyroclastic material, which is specifically the magma that was flung through the air when the volcano blew up. You see rhyolite like this, along with another volcanic rock called andesite, throughout the interior of the state park, part of a formation called the Porcupine Volcanics. And as far as the mid-continent rift goes, it's unusual. The rift was dominated by that basaltic lava. It was much more of a floodplain than an endless chain of volcanoes. So in that way, Lake of the Clouds is a much more normal location. So the question is, why did rhyolitic magma form here? It's a difficult question to answer. Different magmas form different ways. In fact, one of the biggest things I learned while researching this section of the video is that everything I thought I knew about magma was wrong, to the point where I am considering making a sort of Geology 201 series, just so I can personally understand this better. So if that is something you would be interested in, please do let me know, and let me know if there are any specific topics you'd want me to explore. I'm thinking this series would be for people who already know the basics, who know that like there are 3 basic types of rock and that erosion is a thing, but after that, what would you want to learn? But to make a long story short here, there are a few possible ways this could have happened, and so far as I can tell, there doesn't seem to be one textbook answer for the Porkies. Now, one last thing worth noting. Summit Peak has a tower, and when you climb the tower and look north toward the lake, you're not looking directly at extinct volcanoes. Each peak here does not represent a single volcano frozen in time in the way that you can hike volcanoes in other parts of the world. In fact, these hills in the distance are mostly from basaltic lavas, the stuff that stood tall as the weaker sedimentary rock was worn away. But another reason this rock is so exposed is because around the time the rifting was ending, this region was squished, most likely by an event to the southeast called the Grenville orogeny, which I talked about in my last video. That force pushed these layers of rock into a big arch called an anticline. Then a billion years of erosion sanded off the top of the arch. So you see that old rhyolite exposed at the center of the park, and then the younger basaltic rock, and finally the youngest sedimentary stuff down by the shoreline. Now, this is a simplification. Like, the Porkies really only represents one part of an anticline. But this is a good way to understand why you find old rhyolite in the center of the park and the younger rock down by the water. But really, that is a big thing I love about this park. Its variety. It's a park where you can hike the echoes of ancient volcanoes, but also one where you can see literal wave marks from long-forgotten shorelines. It has rivers and forests and lakes, and because it's managed by the state park system, it's also accessible to the public. The Porkies is one of the first places I ever visited in the Upper Peninsula, and it is still one I find exceedingly magical. And that is not just on the geology. Thanks to UP Travel for supporting this video. If you want to learn more about visiting the Porkies, you can go to uptravel.com and follow them on social media for tips for planning a visit. Thanks as always for being here. I hope you learned something that makes you think about the world just a little differently, and I'll see you soon.